Yes, good evening all of you. Today we will see the continuation of the chemical properties of alkyl halides. Yesterday we learned two chemical properties of alkyl halide. One is alkyl halide will be treated with aqueous NaOH or KOH, we are getting alcohols. And one more neighbor reaction, Williamson's synthesis for the ethers. Whenever alkyl halide will be treated with sodium salt of alcohol in presence of alcohol medium, we are getting ethers. So anyway, these all chemical properties of alkyl halides will be proceeding according to a nucleophilic substitutional reactions. Okay, now I am telling one more chemical property, you see carefully. So generally alkyl halide will be treated with either aqueous NaOH or KOH, we are getting alcohol. But especially in case of tertiary alkyl halide. What is the meaning of tertiary alkyl halide? Halogen having carbon directly connected with how many carbons? 3 carbons. If you take such kind of tertiary alkyl halide, no need to use any NaOH or KOH. Directly will be going reaction with water. Yes. If you take normal water, if you can take, we are getting a corresponding alcohol, we are getting CH3 and OH plus what is coming? HCl is coming. Correct sir, why it is going like this? Actually, if you want to convert alkyl halide into alcohol, we have to use either aqueous NaOH or KOH. But no need to use that, but just if you can use hydrolysis giving reaction. Why? Because means you know very well from water what is coming, H plus OH minus is coming. This OH minus itself it is acting as a which one? Nucleophile. Okay, why it is easily involving the chemical reaction with this one? After breaking alkyl halide means this bond shifting like this, then we are getting here minus, here we are getting a plus. Means after breaking we are getting positively charged carbocation, we are getting. Yes sir? Okay, this carbocation is a something special. Did you observe? This positively charged carrying carbon directly connected with 3 carbon atoms, it is calling as tertiary carbocation. It is more stable particle. That's why always this compound itself it won't easily break down into tertiary carbocation. Then immediately it is attacked with the OH minus, you are getting alcohol. Finally, what happening here? Cl minus is substituted with the OH minus, is calling as a nucleophilic substitution reaction. But if you can take primary alkyl halide or secondary alkyl halide, will not react with water. If you want to convert primary or secondary alkyl halide into alcohol, definitely we should use aqueous NaOH or KOH to produce nucleophile. Keep in mind, whatever something special, they have to focus very carefully. Okay, next I am giving one more chemical property. It is nothing but reaction with ammonia, formula NH3. It's a very simple and very important. It is also going through nucleophilic substitution reaction. Just I will explain to you, you will get it very easy. If you take alkyl halide, whatever it is, alkyl halide should be taken excess. A large quantity of alkyl halide you are taking, just you are taking 1 mole of ammonia you are taking, then getting products will be more than 1. How is that one? I will tell you. Then we are getting primary, secondary and tertiary, and also we are getting primary, secondary, tertiary, amines we are getting, amines we are getting, and also we are getting quaternary ammonium salt we are getting, quaternary ammonium salts we are getting. I will explain, don't worry about this one. We are getting quaternary ammonium salts we are getting. Okay, but how to maintain medium is alcohol medium. What is the reaction? Whenever alkyl halide in excess quantity will be treated with ammonia in presence of alcohol, we are getting primary amines, secondary amines, tertiary amines, and also we are getting quaternary ammonium salts we are getting. I will give you explanation for you. You see carefully. For example, alkyl halide. Take one example for this one, CH3Cl. Will be reacted with which one? Ammonia. In presence of which one? Alcohol medium. First step I am explaining. Okay, first we are reading primary amines. How? According to nucleophilic substitution. You see very carefully concept. NH3, for my convenience I am writing like NH2 and H. Any problem? No. So in between nitrogen and hydrogen sharing going equally or unequally? Unequally, because nitrogen is the relatively more electronegative element. This point, the shared pair of electrons shifting towards nitrogen. Then nitrogen will get spark negative charge and it's becoming a positive charge. Anyway, it will be breakdown like how? NH2 minus and H plus. Now NH2 minus itself is acting as a which one? Nucleophile. Okay, then what will happen in this nucleophile will be attacking on this carbon because this bond is shifting towards chlorine atom, then it is becoming like minus, then we are getting here plus. This positively charged particle is easily attacked by negatively charged particle because opposite charges will attack together. Then what is we are getting? CH3, okay, NH2 plus, what is coming here? H plus and Cl minus, becoming like HCl, otherwise minus HCl, right? Okay, observe over here, the Cl minus is replaced with NH2 minus. Anyway, it is also undergoes a nucleophilic substitutional reaction. This getting product is calling as methylamine. Amine function group, you know, I think NH2. So this is calling as a methylamine. I am telling it is the primary amine. Sir, how can you recognize it is the primary amine? Okay, in that functional group, whatever nitrogen will be there, that should be connected with only one carbon atom. In that amine compound, whatever nitrogen will be there, that should be directly connected with one carbon atom. Then those compounds is calling as a primary amines. Are you clear? Yes. Sir, how you are getting secondary and tertiary and quaternary ammonium salts? Yes, you have to take excess, no? So what you got already? CH3, NH2 you got. Still it is involved in the reaction with which one? Methyl chloride. Is it? Yes. Why? Because so much you are taking, excess you are taking. Then how reaction will be going on? Anybody? Same process amount. Here NH and H it will becomes, okay, for my convenience I am writing like NH and H, then this bond is shifting towards nitrogen becoming like minus and plus. This is acting as a nucleophile attacking on this carbon, immediately this bond will be breakdown. It's becoming like minus and H plus becoming like HCl. After that getting product is what anybody? CH3, NH connected to which one? CH3. This is calling as dimethylamine. It is calling as secondary amine. How can you recognize this is the secondary amine? In this amines, nitrogen atom is directly connected with how many carbon atoms? 2 carbon atoms. Only one carbon connection, primary. 2 carbon connection, secondary. 3 carbon connection, tertiary. So it is directly connected with 2 carbon. That's what it is calling as a secondary amine. It's calling as a dimethylamine. Okay, still capacity is there. Anybody? What is the third step? What do you want right now? CH3, Cn and here H and on it CH3. Still it can proceed in the reaction with which one? Methyl chloride. Yes or no? Same process. This bond is shifting like this. NH better write down like this. We are getting plus here, minus here. Minus is nucleophile attacking on this carbon, while attacking this bond will be breakdown. Cl minus H plus coming outside. After that pair connection, this nitrogen and methyl. What we are getting? CH3, N, on this we are getting CH3 and CH3. It is calling as trimethylamine. It's calling as tertiary amine. Arey sir, why we are calling this one as a tertiary amine? You are seeing very clearly. In amine, nitrogen directly connected with 3 carbon atoms. Still capacity is there. Primary is over, secondary is over, tertiary is over. Now we are discussing about the quaternary. Yes, again that product, whatever it is, CH3, N on it, CH3, CH3. Still it will be reacting with excess of methyl chloride. How this compound is acting as a nucleophile? Anybody? After completion of everything, nitrogen has a lone pair of electron on it. Lone pair of electron is electron rich. Electron rich means acting as a nucleophile. So this lone pair of electron will be attacking on this positively charged copper atom. Immediately this bond will be undergoing a cleavage, means breakdown. Then what we are getting? CH3 N, on it we are getting CH3, and one more new connection we are getting CH3. The whole particle getting positive charge. Why? This is donating electron to this particle. Which bond is forming? Coordinate covalent bond is forming. And one more thing we have to discuss in chemical bonding already we learned. Actually, nitrogen capacity is how much? 3, but has how many bonds? 4 bonds. How much excess? 1 bond excess. Excess is represented by always plus. And what is joining with that one? Cl minus. Anyway, positively charged particle, negatively charged particle, calling as quaternary ammonium salts. So that's why it is only we are calling as quaternary ammonium salts. And no sir, for example, question is given, only one more given, stopped at primary alkyl halide, primary amine. No, he given 2 moles, then secondary amine it will stop. He given excess. Means infinite quantity given, then what will happen? Whatever capacity will be there going on, finally product will be what? Quaternary ammonium salts. He may ask the one more question here. 1 mole of ammonia can consume how many moles of methyl chloride or alkyl halide? 1, 2, 3, 4. Means 1 mole of ammonia molecule has a capacity to react with 4 moles of alkyl halide. Then we are getting which compounds we are getting? Quaternary ammonium salts. These are bits. Nothing to discuss much here. And you have to see, I will explain one more chemical property, reduction. Reduction of alkyl halides. What is the meaning of reduction and adding of hydrogen? Okay, just I will write here, see, alkyl halides will be reduced. Reduced means what? Adding of hydrogen in presence of reducing agents like lithium, aluminum hydride, or you can take some other chemical, zinc and HCl combination, or reduction catalyst is what? Nickel or palladium or platinum. We are getting which compounds? Alkanes we are getting. Very easiest way. Whenever alkyl halides will undergoing reduction with some special reducing agent, you are getting corresponding alkanes. Can you give one example for this one? Take CH3Cl will be undergoing reduction in presence of lithium aluminum hydride. What happening? One hydrogen, one Cl from outside. That Cl is occupied by hydrogen. CH3 and H, CH4. We are getting which one? Methane. And no sir, I will take C2H5Br. Yes, undergoing reduction. Same thing, one H, one Br come outside. Br is replaced with H. Then we are getting C2H6. Like that, alkyl halides will undergoing reduction with their special suitable reducing agent. We are getting corresponding alkanes. Yes. Next, chemical properties is very important. I will give the brief explanation how to understand very carefully. So now, this is one of the important chemical property of alkyl halide. So what is that one means? You see carefully. Alkyl halides is undergoing reaction with either sodium cyanide or potassium cyanide. Same alkyl halide may react with another special compound, silver cyanide. Getting product is changing. That's why while doing organic reactions, we have to maintain a particular conditions as well as particular chemicals to get the particular product. Okay, same alkyl halide will react with sodium cyanide, potassium cyanide. Getting compound is nothing but alkyl cyanides. Alkyl cyanides. Same alkyl halide with silver cyanide, we are getting alkyl isocyanide. Alkyl isocyanide. Okay, why this change is coming? I will give the brief explanation, but how to fix this point in your mind. Whenever alkyl halide will be reacted with those chemicals, we are getting cyanides. Whenever same alkyl halide will be treated with silver cyanide, we are getting isocyanates. We are getting. I will give you one common representation. You take for example alkyl chloride. So they may reacting with which one? Sodium cyanide, or you can use potassium cyanide. It's not a matter. Then what we are getting? Alkyl cyanides we are getting, or C triple bond and we are getting. How can you recognize this is a cyanide compound? From CN group, which is involving in the connection furtherly, carbon atom. From CN, which is furtherly involving in the connection, okay, carbon, then those compounds is calling as a cyanides. No, if you are using which one? Silver cyanide you are using. Yes, then what happening? From CN group, which is involving in the connection furtherly, nitrogen atom. So R is connected with N, triple bond C, here getting plus and here minus. You have to observe very carefully. From CN group, nitrogen is involving in the connection with alkyl chain. Those compounds is calling as isocyanides. Understand why coming like this? Cyanides connection from our connection with the carbon atom of the CN group. Isocyanide from CN group, nitrogen is involving in the connection with the alkyl chain. So why this change is coming? First of all, we have to discuss CN minus. It is coming from sodium cyanide, potassium cyanide, silver cyanide. CN minus is acting as a special nature or nothing but ambident nucleophile. Ambident nucleophile. Yes, did you remember or no? While discussing in basic concepts competitive bits, we used one word, ambitious. Ambitious means what? More than one. Yes, here ambident nucleophile, more than one. What is a more than one? Means in this nucleophile, more than one atoms having a capacity to involving in the connection with the further atoms. Ambident nucleophile means is a special nucleophile in that what is the meaning? More than one atoms. More than one atoms are involving in bond formation. Involving in bond formation with the others. Yes, means what? In this cyanide, sometimes carbon may involving in the bond formation or nitrogen may involving in the bond formation. Such kind of behavior having the nucleophiles is calling an ambident nucleophile. Okay, now first of all, we are discussing how alkyl halides will be reacted with sodium cyanide or potassium cyanide. Why we are getting alkyl cyanides? For example, I am taking sodium cyanide. Do you know the structure of sodium cyanide? Just you see, I will write it here. Sodium, single bond, carbon, triple bond, nitrogen. Did you observe all its constant particle valency will be satisfied? Sodium 1 bond, carbon 4 bonds, nitrogen 3 bonds satisfied. Now we have to observe very carefully. Sodium is which one? Metal atom. This together part is nothing but which one? Non-metal particle. Both carbon and nitrogen is becoming non-metal. Then what happening? Between metal and non-metal, which bond is forming? Ionic bond is forming. So that's why anyway, sodium cyanide is a which compound? Ionic compound. Ionic compound means what happens? It will break down like into ions. How? Metal having a character to lose electron, electropositive element. So it will lose electron, then loose electron is received by carbon. So then what species we are getting actually? Na plus particle plus C triple bond, and where we are getting minus on carbon we are getting. Now this Cn minus is acting as a which particle? Nucleophile. That is important. Okay, now I am taking one alkyl halide, I am taking ID, that is nothing but CH3Cl. It is attacked with which particle? Cn minus. But very carefully have to mention the things here, Cn minus. but negative charge is located on carbon atom. Now what happening? Whenever it is attacking only bond formation with the carbon atom, but not nitrogen atom. Why? Because carbon atom is carrying a negative charge. It will be attacking on this positively charged carbon atom. Immediately this chlorine atom will be coming outside. Then what we are getting? You see carefully. N triple bond C. Connection with CH3, which is coming outside in Cl minus. This Cl minus and this Na plus is becoming like which one? NaCl. Can you write this compound in another way? CH3 C triple bond N. Yes, very clear. From cyanide, which is involving in the connection with other part, carbon only. That's why this compound is calling as a cyanide. Which is cyanide? Methyl cyanide. That's why these compounds is calling as a methyl cyanides. This is very important. How to computative point of view, just you have to remember, whenever alcohol will be treated with sodium cyanide or potassium cyanide, you are getting cyanides. Same compound with silver cyanide, you are getting the reverse isocyanide you are getting. So I explained how you are getting cyanides. Now I will explain how you are getting the isocyanide with silver cyanide. First of all, you have to check the nature of silver cyanide. Okay, same structure, silver and carbon atom, a triple bond with nitrogen atom. But is it ionic compound? No. Why? The silver is a which block element and D block element. D block element means is it having big size? S block bigger size, D block small size, P block very very small size. Why? Because by going right side, size of the atom will be decreasing. So that's why silver atom will be a smaller size than the sodium atom. Then is it more electropositive or less electropositive? Less electropositive. That's why what happening? There is no chance to transfer of electron from silver atom to carbon atom. So then what happening? Little bit sharing is going on between silver and carbon atom. That's why this bond is having which character? This bond is having which character? Covalent character. So it is having little bit covalent character, or in that the bond or having nature is covalent nature. So no chance to get ions. As it is, it will be participating in the chemical reaction. What my point? If you take sodium cyanide or potassium cyanide is ionic compounds, we turn into ions. But silver cyanide is not the ionic compound because small size of the silver, it does not donate electrons to cyanide ion. That's why it's having covalent character. That's why it should not give ions. But how it is participating in the chemical reaction? See carefully. You take CH3Cl. It is attacked by whole molecule. What is the molecule? Ag. Carbon, yes or no? Ag, carbon and triple bond N. Okay, you have to observe very carefully. In this cyanide, where lone pair electron will be there, nitrogen has lone pair, no doubt in it. In every molecule, after bond formation, nitrogen has one lone pair. Now, it is nothing but electron rich center. Electron rich center means can act as a nucleophile. So it will be attacking on this carbon atom. Immediately this chlorine particle will be totally coming outside. Then what we are getting? See here very carefully. Ag, C, triple bond, N. Donating no. Gets which charge? Positive charge. Connection with CH3. Yes or no? And which is coming outside? Cl minus. Is it stable? No. Still it has to be lose something. What is that one? Between silver and carbon, silver is metal, carbon is non-metal. That's why this electron is shifting towards carbon atom. Then we are getting here plus, here minus. That's only right down here. What is coming? C triple bond N, and we are getting CH3. Here plus charge, here minus charge. After that, Ag plus and Cl minus is becoming like AgCl. Observe this compound very carefully. In this cyanide group, connection through which atom? Nitrogen atom. Connection through nitrogen atom is calling as. So what is the name of this compound? Methyl isocyanide. Methyl isocyanide. Did you understood? Yes. Like this, yes. Generally we get this is enough for your board examination. But why happening like this? So if you take sodium cyanide or potassium cyanide having ionic compound character, that's why split down and freely we are getting nucleophile attacking through carbon atom, this way we are getting cyanides. But here silver cyanide has a covalent nature, that's why no chance to get any ions. Then whole molecule will be attacking on this alkyl halide through nitrogen atom. Why? Because remaining one having lone pair. Nitrogen only having a lone pair. So lone pair species means electron rich species, so they are acting as a nucleophile. So they can attack in lattice will be going on. Finally, from Cn, which is involving in the connection nitrogen, so we are calling them as isocyanates. All of you clear?